All right, spring in the grocery scale, produce scale is stretched 0.03 meters when 2 kilograms of oranges are placed in the basket. Find the spring constant for the scale, and then find what the period of the scale will be if it's allowed to oscillate. So I've got this scale here. It's attached to a spring. Okay, and I've got my oranges in it. Okay, and it tells me that when I put 2 kilograms of oranges in it, it stretches 0.03 meters. So it stretches down 0.03 meters. That looks like 3.03. It stretches, that's not a 3. There we go. It stretches 0.03 meters when I put the oranges in. Okay, and I want to know the spring constant and I want to know the period. So I know how far it stretches, so the displacement of the scale is negative 0.03. And if you're wondering why am I doing negative, it's because it's stretching it down. So that's going to be the negative direction. It's stretching it out. I usually make stretched out negative. That's just what I usually do to be consistent. And then it tells me the mass of the oranges is 2. Okay, that's all I got so far. So A. A wants to know what the spring constant is. Well, in case you forgot, spring constant is K. So we're solving for the spring constant. So I'm looking at my simple harmonic motion in waves, because that's the unit I am. Springs are simple harmonic motion. So I'm looking for the spring stuff, and I've got 2 spring things here. Okay, we got period for the spring, and we've got just the force on the spring. It's up to you. Like it will help count towards the. Like, you'll need to label, like, the symbols on the equation sheet, but, like, this will help get you bonus points for the equation sheet. Like, it's a good starting point. Okay, so those are the springs equations. All right, K is the spring constant, and you're looking at this and you're saying to yourself, well, Mr. B, K's in both of them, so how do I know which one to use? Well, this one talks about the spring oscillating up and down, and this one is just the spring stretching out. Well, that's all that's happening. I'm just stretching out the spring. I'm not bouncing it up and down, at least not for A. So that tells me that the equation I want to use is the spring force equation. This one. Okay, so I'm ready for this. Equals negative K. K is what I'm solving for. D is my negative 0.03. But the problem is, what is the force? Well, the temptation is to plug in 2. The mass is 2. Well, the mass isn't 2. Or sorry, the force isn't 2. The mass is 2. But mass causes a force, specifically the force of gravity. So why does the force of gravity matter? Well, the force of gravity matters because that is what the spring's force is. The spring applies as much force as gravity pulls down. So this force here, the spring force, is the force of gravity. So if the force of gravity is 19.6, then the spring force is 19.6. Notice I didn't put a negative there because it's not really gravity. It's really the spring that I'm worried about. And the spring force is up against gravity. That's why it's positive. Okay, negatives are going to cancel. Divide both sides by 0.03. And we get my spring constant to be 653.3. Okay, so now I need to find the oscillation, it says. So now figure out the period if it were allowed to oscillate. So period is capital T. If I look at my equation sheet, there's only one equation that deals with period and springs, this one. So that's got to be my equation. So period for the spring equals 2 pi square root of m over k. So period equals 2 pi square root of 2 over 653.3. And now you just do all the math. Okay, 2 pi is 6.28. And the square root of that answer is 0.055. So I divided 2 and 653. When I divided those two, I got 0.00306. Then I square rooted that number, and that gave me the 0.055. Multiply that by the 2 pi, and I've got a period of 0.348 seconds. Okay. Any questions there?